All right, in the last video, we decided to find the full circumference of a circle. In this video, we're going to just try to find certain arc lengths. So in this case, we have angle ABC, and we're asked to find the arc length A to C. So it's basically a part of the circle we're trying to find. So this is related to circumference. In fact, we're going to start by finding the circumference in most cases. So remember, the circumference is 2 pi r. So the idea is the arc length is going to be a fraction of that circumference, depending on how much of the circle this represents. So basically, the formula for arc length is going to be some fraction times the normal circumference. Now, what this fraction is, we're going to figure out in a second, and I barely spelled fraction correctly. But here's what we're going to do. Let's start by finding this 2 pi r. So 2 pi r would be 2 pi times 4. That would be the full circumference. So if I want to find the arc length here, I say, what fraction of the circle does this represent? Well, it says here this is an 80-degree angle, and we know that a full circle is 360 degrees. So this part of the circle represents 80 of the total 360. So if we do 80 over 360 times the normal circumference, that will give us the arc length. So what we do if we start reducing, we get 80 over 360 times 8 pi equals the arc length. And if you have a calculator, you could simplify this, but if you're not allowed to use the calculator, we just got to start reducing. So 80 over 360, we can go to 40 over 180 times 8 pi, and just divide by 2. Then we go to 20 over 90 times 8 pi. Then we could go to 2 over 9 times 8 pi. And then 2 times 8 is 16 pi over 9. And I think that's as reduced as we're going to get. So in this case, the arc length here is 16 pi over 9. So that is the full, that is how long this part is here. All right, now moving on to a slightly different one. In this case, I know the arc length. They're telling me this is 6 pi. And I want to find I know the radius of the circle, I want to find the measure of this angle. So once again, we can say, well, arc length is going to equal some fraction times the total circumference, 2 pi r. And so we say, okay, what do we know in this situation? So we know the arc length is 6 pi. So what we don't know is what fraction of the circle is this. And then 2 pi times r, 2 pi times 12. So we know this. So we have 6 pi equals some fraction times 24 pi. So the pi's can cancel. We can solve, and we find the fraction equals 6 over 24. So 1/4. So what fraction of the circle are we looking at? We're looking at a quarter of the circle. So how many degrees is that? Well, remember there's 360 degrees in a full circle times 1/4. So this is 90 degrees. That's how we can figure this out. And then we can go back and do it again. We can rerun this forward. So the arc length should equal 90 out of 360, right? Because the fraction is 90 degrees out of 360 times 2 pi. And it said r was 12, and so we can double check this. So if we do this work out, 2 pi times 12, as we said, was 24 pi. 90 over 360, we figured out was a quarter. So 1/4 times 24 pi gives us 6 pi, which was, again, what the arc length was. We can always just kind of run this in forward motion. So this is how we solve circumference and arc problems using equations. We're going to look at another way to do this in the next video, but this is one method you can use. So until next time, I am Derek Genova. Have a delightful day.